This is an overview of the processes, management tools, automation, and so on that make Exadata easy to maintain and secure and operationally efficient. The focus here is reducing risk to the business and making sure that you get to go home earlier each night. I'm going to hand you back to Cyril, who will be presenting along with Matt Gallagher. Matt is based out of Chicago.
Hello, and welcome to the second session in our Introduction to Exadata series. Here, we'll be introducing you to the Exadata operational best practices. During the course of this presentation, we are going to cover how to secure an Exadata, explore different ways to monitor an Exadata, methods to check the health of an Exadata. We will also provide you with an overview on exploring the Exadata storage and database performances. We will walk you through a few methods of patching an Exadata and provide you with a list of resources to implement the best practices we will cover during this presentation. Exadata automates and simplifies a lot of administration tasks for you. Both the database and system administrators will have less to manage, helping them leverage their time for more productive work. When delivered to a customer, the Exadata comes in fully pre-installed, pre-configured, pre-tuned, and pre-debugged. The entire stack from the operating system, networking, grid infrastructure, and database is installed and configured with the database instance already running and ready to load your application data. Exadata has a bunch of tools which validates itself against best practices and compliance requirements in a continuous and periodic interval. We will be going through some of these tools during the course of this presentation. Oracle provides a dedicated engineered systems Exadata team for all support requirements, encompassing 24/7 monitoring for the entire stack. This is the Oracle Platinum support team. OEM, Oracle Enterprise Manager, provides a single monitoring and management pane for an entire Exadata, making it easy to monitor and maintain an Exadata system through its life cycle. Let's now look at some of the Exadata security features. Exadata has full stack security built into it when delivered. Exadata has the added advantage of community effect with tens of thousands of identical deployments in the market. Most telco, banks, retailer, credit card companies, insurances run their Oracle database workload on an Exadata thanks not only to its amazing performance, but superior security offerings as well. Exadata is FIPS 142 and PCI DSS compliant. FIPS, the Federal Information Processing Standard, specifies the security requirements that will be satisfied by a cryptographic module, providing 4 increasing qualitative levels intended to cover a wide range of potential applications and environments. PCI DSS, on the other hand, is the payment card industry security standard followed by all major payment card companies. 8, the Advanced Intrusion Detection Environment, is a file and directory integrity checker. It comes pre-configured in an Exadata. The customer also has the ability to customize the 8 template as desired. It enables a customer to check if any critically deemed files are updated or changed either in content or permission. Exadata security begins at Power Up with Secure Boot. Secure Boot ensures that the firmware will only allow the execution of crypto-signed bootloaders that the system recognizes as trustworthy. With each reboot of the server, every executed component is verified. This will prevent any malware from hiding embedded code in the boot chain. The Oracle Enterprise Linux distribution is also stripped down to bare minimum requirement for running an Exadata. This eliminates any security compromising RPMs and libraries being loaded. The pre-installed UEK5 kernel is custom built to run an Oracle database on an Exadata. We then also have the Secure Arrays solution, which is NIST SP 800-883-R1 compliant. Secure Arrays, as the name suggests, helps you to securely erase all data on both database and storage servers when the Exadata has to be decommissioned and or repurposed. Secure Arrays will sanitize all storage media, including hard drives, flash devices, and internal USBs in an Exadata. We also have ksplice, which provides the ability for live kernel patching in Exadata. It may be used in cases where an urgent runtime security vulnerability or a stability bug has to be applied without rebooting the operating system. Often overlooked, but one of the most important best practice of keeping your Exadata secure is to be able to patch the entire Exadata stack to the latest update available. Oracle makes it easy for you to be updated by providing 4 free patching cycles a year via the Oracle Platinum support. Oracle also offers additional methods of patching in Exadata, which we will discuss later today. Other best practices to follow to lock or harden the compute and database servers are to disable direct login of privileged users on database nodes. Only enable root login during patching and upgrade events as required. You can also use tools like sudo or pbrun to perform privileged user tasks on the database nodes. Exadata provides you with the ability to also implement STIG or SCAP standards across the database nodes. STIG or SCAP standards follow Department of Defense security standards. The customer also has the ability to modify the STIG standards to fit their specific requirements. The link below provides a guide on setting up security on an Exadata system. Now that we have secured our Exadata system, let's switch to securing the database. Oracle's transparent data encryption technology, commonly known as TDE, is the most widely used data encryption method for Oracle database. TDE will transparently encrypt data at rest in Oracle databases. It stops unauthorized attempts from operating system to access data stored in files without impacting how application accesses the data using SQL. The encrypted data remains encrypted in the database, whether it is in tablespace, storage files, temporary tablespaces, undo tablespaces, or any other files. TDE tablespace encryption leverages Oracle Exadata to further boost its performance. As an example, Exadata Smart Scans parallelizes cryptographic processing across multiple storage cells, which results in fastest queries on encrypted data. The TDE secure keys can be stored outside an Exadata in a vault, increasing the level of security. Let's now look at the Oracle Database Vault. Oracle Database Vault gives you powerful security controls to protect sensitive data from unauthorized access. It also helps you implement separation of duties between database administrators and data owners to comply with different privacy and regulatory requirements. Labels, data redaction, masking, and subsetting helps to restrict data access by job function. If one division or group is not supposed to access data of a different division or group, the above techniques makes it possible. The URL below walks you through all the detailed database security features for Oracle Database 19c that can be incorporated in an Exadata. Now that we have our Exadata system and database fully secure, let's look at how we monitor them. Oracle ASR, the Auto Service Request offering, is a call home feature of Oracle Hardware Platform. Let's take a look at how ASR works for you. The ASR manager configured in the customer data center monitors the Exadata for any hardware faults at all time using SNMP traps. When a predefined hardware failure happens and the Exadata generates an SNMP trap, the ASR manager picks this trap and logs the service request with Oracle on your behalf. Event notification is always one way, requiring no incoming internet connections or remote access mechanism from Oracle into customer. Notification can only go out to Oracle. The ASR manager then securely transports electronic fault telemetry to data to Oracle to help expedite the diagnostic process. So once Oracle support analyzes the data that's sent and determines the fault, replacement parts as required are dispatched to the customer's site along with a field engineer. The ASR manager updates are also periodically released and updated automatically by default. Automated cloud scale monitoring feature is built into Exadata Storage Software 19. The X8M hardware comes pre-installed with Exadata Storage Software 19.3, which is not to be confused with Oracle Database 19c. Exadata Storage Software 19 supports database version from 11.2.3.4 all the way up to 20c. Exadata 19 has a management server daemon running on all compute and storage servers within the Exadata. This management server monitors parameters like CPU, memory, network, and process states. The management server daemon takes actions and sends notification in real time. Events like high CPU utilization, memory exhaustion, or leaks, processes hung or stuck in D state, high swapping, inconsistent client response time, flaky network connections are all continuously monitored and reported on. Exawatcher. Exadata also comes pre-installed with an extremely nifty tool called the Exawatcher. Exawatcher runs as a daemon on all Exadata nodes, collecting information pertaining to performance metrics. Exawatcher also comes with a script called the get Exawatcher results, which is used to obtain pertinent statistics for a specific time period when there probably was a performance degradation for further analysis. Exawatcher now also comes with graphical representation of all the performance statistics collected for a selected time period. We just took a look at ASR, the management server, daemon, and Exawatcher as tools to monitor an Exadata. Let's now look at Oracle Enterprise Manager. OEM is another offering from Oracle to manage and monitor Exadata. OEM provides a single pane view for not only the entire Exadata stack, but also for the entire engineered systems portfolio. Some of the key features of OEM with respect to managing an Exadata are monitoring hardware, software, and the entire database stack, patching and provisioning the entire stack, feature support like virtualization. OEM also helps in compliance management. OEM agents can be pre-installed on all Exadata components during the deployment stage. OEM has a plugin specifically for Exadata, which is then used to discover the Exadata stack from the OMS server. OEM makes it possible to have a unified view of the Exadata hardware and software. It now also provides a photorealistic view of the Exadata. By hovering the mouse over the photorealistic view of a component, every detail about the component like status, make, model, serial number can be obtained right there. OEM has a preset monitoring template used for hardware, software, database, grid, and ASM alerts. The customer also has the ability to customize the parameter and values within the template and also create custom monitoring rules as desired. This slide provides a pictorial view of Exadata storage node in action. This is the home page of a single storage cell. OEM captures Exadata specific metrics like status, storage software version, average flash and hard disk response time, capacity metrics at disk and disk group level, I/O distribution metrics like service times, etc. OEM can also be used to run XRCLI and CellCLI commands. OEM also helps in setting up IORM routes. OEM 13.4 now provides a Grafana data source plugin, providing the ability to create requisite dashboards on Grafana. You can also visualize data from different EM sites, time series databases, or other analytical tools into a single dashboard panel on Grafana. OEM will be covered in much deeper detail in our Advanced Exadata Workshop series. Oracle Platinum support is the optional 24/7 free monitoring support that comes pre-bundled with an Exadata. Oracle monitors your Exadata environment for you via the Oracle's advanced support gateway that will be deployed at your data center. The Platinum support team will monitor for faults in hardware, database, operating system, and networking components. Platinum comes with 5-minute fault notification, 15-minute restoration or escalation to development promise, and a 30-minute joint debugging with development on 7 tickets. Again, just to wrap this up, Platinum service from Oracle comes at no charge for you, the customer. We now have Matt Gallagher, who will walk you through the Exadata health check and performance analysis section of this presentation.
Next, we're going to talk about Exadata health checks. Exadata includes 2 tools, ExaCheck and TFA, that are diagnostic tools that have been in use for quite some time. ExaCheck health checks the entire Exadata system and the database, while TFA collects and packages diagnostic information for support. They had both been standalone tools and deployed and updated separately. In version 19.3 of the Autonomous Health Framework, which was released in October 2019, both tools have been incorporated into the Autonomous Health Framework. They're both now packaged, installed, and maintained together under the Autonomous Health Framework. Oracle best practices recommendations are to upgrade to the latest version of the Autonomous Health Framework as new versions are released to run the latest ExaCheck when health checking systems, and TFA when you're extracting diagnostic information for support. Starting with release 19.3.1 of the Autonomous Health Framework, you can also install ExaCheck by itself. ExaCheck has a health check catalog that documents all the health checks that are performed. ExaCheck is designed to identify and prevent engineered system and database issues that could possibly impact stability and availability. Think of it as an early warning system. This is just one of the many features designed to maximize availability. Issues and findings are ranked according to the potential impact they could have on the system. The ExaCheck findings can be integrated into OEM to centralize Exadata and database monitoring and management. OraCheck is the non-engineered system version of health checks. Many of the checks are common between ExaCheck and OraCheck. The Autonomous Health Framework also supports specific profile checks, which include health checks for many components, such as Oracle applications, OEM, clusterware, and ASM, among others. The Autonomous Health Framework has a very extensive user guide that details changes in each release. The user guide also contains the detailed instructions for automating the collections, setting up the email notifications, and special considerations for running ExaCheck on Exadata and other engineered systems. There are many fine-grained control options that are available to you to provide you with everything you need to manage the Autonomous Health Framework in the manner that works best for your company. You'll find the manual posted in the Engineered Systems Documentation portal on docs.oracle.com. ExaCheck is constantly being updated through a continuous weekly feedback cycle. Feedback is received from development, support, product management, and new release testing. Concurrent with updating the health check tool, the changes are also published in the Exadata Best Practices Oracle Support Note 757552.1. The Autonomous Health Framework is a major innovation focus for Oracle. Traditionally, you would see Autonomous Health Framework and ExaCheck new releases probably around 3 times a year. Recently, new versions have been released much more frequently due to all the Autonomous Health Framework innovation that has been ramping up. As you can see, ExaCheck reports an overall system health score. A score of 90 or higher is recommended. In addition to the health checks, ExaCheck inventories all of the grid, database, and engineered system configurations and hardware components. When a question comes up, such as database home specifics or the Exadata and database versions and patch levels, we'll often request customers run an ExaCheck report to answer those questions. Different levels of tests are available, such as critical, pass or fail, warnings, and informational messages. The standard ExaCheck recommendations are to first run an ExaCheck at least monthly, run the health checks before and after configuration and software changes such as patching and upgrades. Always run the latest version of ExaCheck because new checks are added in each version. And finally, track the health check scores on an ongoing basis and the progress for resolving the issues you find. In the display, you can see there are 5 Oracle homes of various versions deployed and a total of 17 databases on an X2 Exadata system with 2 compute nodes and 2 storage souls, which is not very typical, and 3 InfiniBand switches, which tells you a spine switch and 2 leaf switches have been deployed. The ExaCheck version and collection dates are also listed. So you'll here see a small display of an ExaCheck report. So the status is displayed as pass, fail, warning, and critical. All the Exadata compliance MAA best practices are checked against the system and reported. ExaCheck is regularly updated for new recommendations and software releases. Here you'll find that some checks passed. You'll see a listing of the checks that failed. You'll see that some checks were listed as critical, which means they could severely impact the system operation. And then finally, there's a view button, which you can drill down to see the details of each check. And here you'll see a description of the recommendation. It'll also detail the systems that the finding exists. And then finally, it'll have more detailed information, such down to the code that was run to detect that problem, and then some of the technical details on what the check performed. Oracle Enterprise Manager has an Exadata-specific plugin, similar to the plugins available for other Oracle engineered systems. The ExaCheck plugin is deployed by default in OEM 13C. The plugin is used by OEM to discover all the Exadata components when systems are deployed. Exadata is an OEM target type. Exadata has its OEM deployment, configuration, and management manual, which is included in both the Exadata and OEM documentation sets. A key task is to check the certifications to validate the minimum OEM versions needed to support new Exadata deployments. The Oracle support note that covers these certifications is detailed in note 1626579.1. OraCheck and ExaCheck compliance check results can be integrated into Oracle Enterprise Manager. The Enterprise Manager 13.3 releases support integration with Oracle ExaCheck and OraCheck itself through the OraCheck Health Checks plugin. The OraCheck and ExaCheck results are integrated into an OEM compliance framework. Integrating the health check results into the OEM compliance framework enables you to display compliance framework dashboards and browse checks by compliance standards. In this display, you can see a compliance dashboard. As an example, you can see the compliance score for the database instance checks was 87%. In this context, compliance check means passing the health checks best practices and not anything related to security checks. Related checks are grouped into compliance standards where you can view targets that were checked, the violations, and the average compliance scores. From within a compliance standard, you can drill down to see individual check results and break out the results for each OEM target. The OEM ExaCheck integration supports first converting the health check results into compliance standard violations and associating the OraCheck results or compliance standard violations with the appropriate targets. Integrating OraCheck and ExaCheck results in OEM is now covered in the Autonomous Health Framework User's Guide. This slide shows the compliance drilled down 2 levels below the compliance dashboard. The first level would show the compliance standards, including the compliance standard name, the target type it applied to, the compliance standard status, and the summary of passes, fails, warnings, and the compliance score for each standard. The graph shows an example of the compliance standard drill down details. Compliance checks are displayed on the left. On the right are pie charts showing the target scorecard breakdown by compliance factors and rule evaluations broken down by the statuses. Below the pie charts are targets and their compliance scores related to the specific compliance check. You can also view the number of violations. If the Oracle Trace File Analyzer detects any problems, then it performs the following actions. TFA will first run the necessary diagnostics and collect all the relevant log data at the time the problem occurred. The key feature of TFA is that TFA knows which specific files need to be mined to extract the required diagnostic data. TFA will trim the log files to collect only the log entries necessary for the specific diagnosis. This is usually a time-based selection. The trim diagnostics are collected from all the nodes in the cluster and consolidated onto a single node in the Trace File Analyzer repository. This saves a great deal of time in providing diagnostics to Oracle support. TFA can automatically send you email notifications of the problem and notifications of the diagnostic collections that are ready for upload to the Oracle support. Oracle Trace File Analyzer also has a flood control mechanism that prevents repeat errors from overwhelming your system with excessive automatic collections. Support has tools to mine the TFA-produced logs that automate the SR analysis and reduce the time needed to respond to a problem. TFA is part of the Autonomous Health Diagnostics Framework. The Autonomous Health Framework packages many diagnostic tools together and is a major focus area of Oracle development, including incorporating machine learning into the diagnostic process. Now we're going to talk about Exadata Performance. Most DBAs are familiar with running AWR reports to review database performance issues and understand the workloads for a database. However, if the AWR report is running on a database residing on the Exadata platform, then a great deal of Exadata performance data is automatically pulled into the report. On an Exadata, the end section of the AWR report contains extensive Exadata storage performance and I/O volume information. By default, AWR snapshots are taken on hourly intervals, and the snapshots are maintained for 8 days. The default SQL statement capture is 30. Most production systems require performance information be available for 30 or more days, which is easily changed in the AWR configurations. Longer retention periods help compare performance and changes between AWR reporting periods. Production systems often require an increase in the number of SQL statements captured above the default of 30, especially data warehouses, databases. Best practices recommend taking AWR baselines periodically at peak periods. Baselines retain AWR history because they're exempt from AWR snapshot purging. Reporting periods can be compared using snapshots and baselines to compare normal processing periods to problem periods to identify the specific metric changes that occur during the problem period. So here's an AWR for an Exadata system with a deep dive storage report. So only on the Exadata platform, you'll see these types of statistics added automatically, including I/O volumes, the I/O distribution across disks, the reason for the I/O, the latency for each part of the storage tier, including flash, persistent memory, and hard disk performance. It'll show the smart scan volumes. Any capacity issues are flagged or color-coded. So for example, on the right, you'll see there's some capacity issues identified. It'll actually flag that in red, so you can quickly look at your AWR report and tell there's an issue that needs to be looked at. Now, just because capacity has been reached doesn't mean that the user activity or the database transactions are going to have a problem. Or Exadata has an automatic I/O management system called IRM, where the default is just to basically just let it act on its own to make decisions about how to prioritize IOs. And many times, even if a capacity issue occurs, the system will still prioritize the user workloads above all other workloads. AWR report will also include the IO statistics for the top 10 databases. And finally, there's a really good white paper that's available that details all these Exadata AWR features, and there's a link to that in the paper. Here's an example that shows on an AWR report for Exadata on the new X8M systems persistent memory in action. So at the top, you can see the amount of persistent memory that exists on each one. In this case, there's 3 storage cells. Each storage cell has 1.5 terabytes of persistent memory. Now, below is the I/O latency, or the physical I/O latency for cell single block physical reads. This is basically single block access, which on a non-Exadata report would look like DB sequential file read. So here, physical I/O read latency has been reduced from an average on an Exadata system in the earlier versions from 0.2 milliseconds to 0.018 milliseconds, which is a 91% decrease. And you'll see on the AWR report of the 18 microseconds, or millionth of a second, okay, on a 19C database, which again is a 91% decrease. So here's just an example about how you can actually improve transaction throughput on an Exadata system. Here again, you have an X8M system with persistent memory, all right? And here it's specifically focusing on database commits. So if you take a look at the time, the testing that was run on a non-X8M system without persistent memory, the commit time, even though it was excellent, was 414 microseconds. On an X8M system, that dropped to 53 microseconds, or it was an 87% decrease in commit latency. And then finally, you'll see log file parallel writes, which is the actual write event for the commit traffic. That decreased from 161 microseconds down to 19 microseconds, or again, an 87% reduction in latency. And this is why Exadata is the fastest database machine ever built. So Cyril's going to take over now and talk about Exadata patching.
Thanks, Matt. That was extremely informative on how to run health checks and watch for your performance on the Exadata. Let's now turn our attention to how to keep the Exadata up to date with the latest patch sets. Exadata patching can be split mainly into 2 sets. One, the Exadata storage software patching. This encompasses operating system, firmware, and ILOM of the compute and storage servers. It also includes the Rocky switch firmwares. The second set is called the QFSP, or Quarterly Full Stack Patch, which involves patching the grid infrastructure and the database homes. Oracle releases the Exadata storage software patch every month, while, as the name suggests, the QFSP is released every quarter. The document 888828.1 is the document that encompasses all things Exadata patching, and the first thing to be considered when looking to patch an Exadata. It covers all information, including available patches, dependencies, supportability, and appropriate readmes for patching your Exadata. Customers have the ability to keep the Exadata updated via different patching methods. You can either use the Oracle Platinum Service, Oracle Enterprise Manager, Oracle's Fleet Management, or by using the built-in automated patch manager toolset. A bit earlier in this presentation, we took a look at making use of Oracle Platinum Services for monitoring, but that's not all they do for you. Platinum Services also offers free remote patching for the entire Exadata stack. This remote patching service is provided 4 times a year, either in a rolling or in a parallel fashion based on your requirement. The patching will encompass the operating system, the and firmware requirements on the compute and storage servers, the Rocky switch firmware, grid infrastructure, and database homes. Let's now look at what is involved in patching the entire Exadata stack with Platinum. The patching involves 6 stages, from initiating the patch event to verifying and closing the patch event. The good thing is, those are the only 2 tasks you, the customer, will have to do. The remaining tasks of patch assessment, patch planning, patch downloads, and pre-checks, including patch execution, are all handled by Oracle Platinum team for you. It is expected that the customer initiates the patching event at least 4 weeks prior to the day of patching via a support request. The ACS patch coordinator will then contact the customer and start with patch assessment and then create a patch plan. 2 days before the patching event, ACS will download the required patches and carry out the pre-check. The pre-checks make sure there is enough space, there are no potential hardware errors or anything else stopping the patching event from going ahead. During the patching event, the SR is raised to a SEV1 and communications are recorded while Oracle begins executing the patch plan. On completing of the patching, the customer verifies everything and closes the SR. Our good friend OEM, as we have seen above, not only helps in monitoring and compliance, but also helps in patching an Exadata. Up until OEM 12C, only the Oracle database could be patched from OEM. With the release of 13C, we can now patch the entire Exadata stack, either in a rolling or parallel fashion. Let's now look at the OEM 13C window pane, where an Exadata storage cell is being patched in a rolling fashion. We can see that there are totally 6 targets, of which 1 update is in progress and the remaining 5 need to be updated. On the top left, we see the recommendation of the patch to be applied. The same patch we see is being applied to one of the 3 storage cells. We can select, download, analyze, deploy, and even roll back a patch from within the OEM. Patching status can be tracked from the OEM with fine-grained logging. Patch manager logs are available right within OEM for analysis. Oracle Fleet Management is another method which can be used to patch an Exadata. This is one of the preferred methods for patching a large-scale Exadata deployment. Fleet is designed to patch Exadata and Oracle database at cloud scale. It also provides the ability to patch either in a rolling or parallel fashion. Fleet can be configured to run on a schedule by pointing the Exadata to the software repository and providing it with a specific patch window. Fleet will also handle any dependencies between the system autonomously. If, for any reason, you choose not to patch the Exadata, either using the Platinum services, OEM, or even Fleet Management, Oracle provides you with an inbuilt patching tool called the Patch Manager to patch the Exadata storage software. Patch Manager can either be run within the Exadata being patched, or from a different Exadata, or from a completely different server running Oracle Enterprise Linux. You again have the option of patching either rolling or in parallel. Below is the syntax of using Patch Manager. You invoke the Patch Manager, calling out the component to be patched, the list of components to be patched, and the action to be performed. The rest, including the pre-checks, backing up the operating system, and patching the Exadata storage software, is done by the Patch Manager for you. Patch Manager can also be used to roll back a patch on an Exadata storage software in case of any issues.
So next, we're going to cover Exadata operational best practices. And thank you, Cyril. That was a great presentation detailing the value of patching. And preventing customers from having to do their own patching. So letting Oracle do that patching for you can save a lot of time and expense and just effort to keep all the systems updated. So finally, Cyril and I are going to leave with just some great resources on operational best practices that you can further read, how you can achieve excellence with the Exadata platform. Thank you.